Hello, my name is Neil Tomson. I'm an assistant professor in the chemistry department at Penn. My group performs synthetic inorganic and organometallic chemistry aimed at large-scale energy challenges. Feedstock chemicals like dinitrogen, methane, and water can be envisioned to take part in the future energy economy. But to do that, we need to convert these feedstocks into alternative fuels like ammonia, methanol, and hydrogen. Well, my group studies ways to lower the energy barrier to forming these alternative fuels. And to do this, we design new molecular compounds that take inspiration from some underappreciated aspects of biological and industrial catalysts. So please take a look at our group's open house brochure, our website, and our publications to get a better view of the work that we do. And feel free to ask questions. We're happy to talk about the fun and exciting chemistry going on in our group. We have a wonderful collection of students and postdocs. I'm so very proud of how hard they work and how well they support each other. People who have graduated from the group have gone on to positions in industry and academia. And with more people graduating this year, I'm certainly looking to recruit new students in the fall. For now, I'll turn it over to Alex Weberg, one of our senior graduate students, who will give you a virtual tour of our laboratories.
Hi, I'm Alex. I'm a graduate student in Neil Tomson's lab, and today I'm going to give you a virtual lab tour, which is a little different than normal. See, I'm wearing 2 face masks for double the safety and double the fun. So let's head into the lab, but first we're going to need some PPE. All right, come on in. So the first thing that you'll notice here is our solvent purification system, or SPS. And this is a really nice piece of equipment for getting deoxygenated and dry solvent out. A lot of our chemistry is really sensitive both to oxygen and water, and this really speeds up the process so that we don't have to distill everything. On your right, you'll see that we have a bunch of these ovens throughout the lab. We currently have 5. These heat our glassware to about 150 degrees Celsius, in some cases hotter. That allows us to get all the residual water removed before we pump those onto our schlenk lines or bring them into our glove boxes. Each hood is outfitted with a really high-performance schlenk line. So every person that's in our lab has their own schlenk line that they're responsible for caring for, but then that also gives you a huge amount of freedom. It's cut to a montage.
Why do you fill me up, buttercup baby, just to let me down, and mess me around, and then worst of all, never thought, baby, when you say you will, but I love you still, I need you, more than anyone, darling.
If you follow me over here, this is a super cool gizmo, the Biotage auto column. We don't do a huge amount of organic synthesis in our lab, but when we do have to make our ligands, it saves quite a bit of time. The program allows you to select different solvent combinations and different solvent gradients, and really helps separate compounds that have really similar polarities, using a lot less solvent and a lot less time. If you follow me over here, we have these really nice office spaces with wonderful view. Here's Sam Brooks modeling. You can follow me around this direction. We have our UV-Vis spectrometer. What's especially nice about our setup is that we have this Unisoku cryostat so that we can modulate the temperature while we do our UV-Vis measurements. It's cooled through a liquid nitrogen reservoir that sits above it. And you can bring this down to liquid nitrogen temperatures or go as high as 100 degrees Celsius. It's really, really useful for a lot of the chemistry that we do in our lab. On the other side here, we've got a single glove box. This particular glove box is used primarily for electrochemistry or cyclical chemistry. So it's really nice to have an inert atmosphere to do those measurements. So we're going to head across the hall now. On the left here, this is one of our many freezers. This particular one goes to -20 degrees Celsius, and that's really useful for doing crystallizations and storing, sensitive chemicals. Right here we have a rotobap, and this is actually a really nice rotobap. Again, we don't do a huge amount of organic synthesis, but when we do have to make our ligands, this is a really nice piece of equipment. We currently have 2 of these. Most of our base pads we keep in these 20-liter buckets that go in the system. So everybody, like they have their own schlenk line, everybody has their own base pad, so that gives you a lot of freedom. All right, here we have one of our double glove boxes that go under an inert atmosphere. Like I said, a lot of the chemistry that we do in our lab is both water and oxygen sensitive, and so this really speeds up the process for doing our inorganic synthesis. This particular box, we use solvent in it. We also have vacuum systems so we can remove solvent under reduced pressure. glove box montage. First of all, we have another freezer. This one goes down to negative 80 degrees Celsius. Here we have our second double glove box. So normally 2 people could use this at one time, but during the pandemic we have a policy for only 1 person at a time. Like our other double glove box, this one has a vacuum line that goes straight into the box. You can pump off solvents for your reaction. We of course use NMR spectroscopy. We have a really world-class facility down in the basement of the adjacent building. But what's really unique is that we also have 2 spectrometers literally right outside the doors of our lab. On the right here we have a 400 megahertz NMR spectrometer. This is probably the one that people in our group use most often. And then on the other side of the hall we have a 300 megahertz spectrometer. Besides that, our bread and butter as inorganic chemists is X-ray crystallography. Our crystallographer Pat and Mike run a top-notch facility down in the basement of the adjacent building. If you're interested, as a student, you can become trained on using the diffractometers. Shown here is Ariana using the facility to attain a new crystal structure.
Don't stop me now. I'm having such a good time. I'm having a ball. Don't stop me now.
So that's our lab. Hopefully that gives you an idea for the types of facilities we get to work with every day. If you have any questions, please don't hesitate to reach out either to Neil or any of our group members. Here's Neil's email, and then below it is our group website where you can find the rest of our emails. So hope to see you next fall.